A very good morning to everyone. Myself, Dr.P.SEVVEL, Professor, Department of Mechanical Engineering, S.A.E.C Engineering College and Autonomous Institution and Institute Level Research Center affiliated to Anna University, Chennai 77. Today, we are going to see the GATE class with respect to mechanical domain, and today our topic is welding and joining process. So we are going to see in detail about what are all the questions which have been asked in the previous GATE question papers with respect to manufacturing domain and especially with respect to welding and joining process. So if you are going to see this question pattern, so before moving on to the questions which has been asked in the previous GATE question papers, I am going to give you a outline or a simple brief about the question paper pattern in your GATE exam. So if you are going to see the duration, it is going to be 3 hours. And what is going to be the mode of examination? The mode of examination is going to be CBT, that is it is a computer based test. And most important thing, type of questions. What are all the type of questions which are going to be asked in this GATE question paper? So first type is going to be your MCQ, that is multiple choice questions. Second one, it is going to be called as your multiple select questions, that is MSQ. So that you will be having 2 or 3 correct answers. So in a multiple choice questions, you will be having only one correct answer. In MSQ, that is multiple select questions, you may be having 2 or 3 correct answers. Most probably it will be having 2 answers will be right. Next. Third type is going to be numerical answer type, that is NEIT questions. It is going to be completely problematic type of the questions. You have to solve, you will not be given any answer as options. You have to solve and you have to write the correct answer. Next, how many number of questions are going to be asked? Total number of questions is going to be 65 and the total marks. The total marks, it is going to be 100. And how many number of sections? Sections may be 2 or 3 depending upon the paper. That is on what domain? Mechanical domain or computer science or EEE or EC, based on the domain, you are going to have 2 or 3 sections. Next, section wise weightage. So what are all going to be the weightage given to each and every section? If you are going to see this, first it is going to be general aptitude, which is going to be 15 marks. Next, you are going to have 13 marks weightage for engineering mathematics. Then the third thing is going to be subject based questions, that is mechanical engineering means it is going to be questions relevant to mechanical engineering, and it is going to carry a huge weightage of 72 marks. So the total marks is going to be 100 marks, as you can see in this screen. Next, marking scheme. If you are going to see that each question carries 1 or 2 marks. Next, negative marking. You are going to have negative marking in GATE, and this is going to be the pattern. For a 1 mark multiple choice question, 1/3 mark will be deducted for a wrong answer. So for a multiple choice question, if you are going to give a wrong answer, 1/3 of the total mark will be deducted for that. Next, for a 2 mark multiple choice question, 2/3 mark will be deducted for a wrong answer. For multiple select questions or for numerical type of the questions, you are not going to have any negative marking. So this is going to be the pattern for our GATE question paper. Next, what are all the subjects we are going to have over here? So under mechanical engineering domain, you are going to have various subtopics, and each and every subtopic is going to be called as a section, and section wise you are going to have this weightage of marks. So first section, it is going to be general aptitude, which is going to be 15 marks, followed by engineering mathematics, which is going to have 13 marks. Remaining 72 marks is going to have a total weightage, as you can see over here. So what are all the subdivisions? If you are going to see engineering mechanics with the weightage of 3 marks, thermodynamics and heat transfer with the weightage of 14 marks, followed by fluid mechanics with the weightage of 10 marks, theory of machines with a weightage of 4 marks, followed by strength of materials, and it is going to have weightage of 8 marks. Then comes your machine design with a weightage of 6 marks. Then comes your production technology, then industrial management and engineering, and production technology is going to carry a weightage of 18 marks, followed by industrial engineering, which is going to have a weightage of 7 marks, and finally comes your material science, which is going to have a weightage of 2 marks, as you can see over here. When you are going to add all these things, you are going to have a total of 72 marks for this mechanical domain topics, followed by engineering mathematics with 13 marks and general aptitude with 15 marks. So totally you are going to have 100 marks, as you can see over here. So this is going to be the weightage or mark split up. So based on this, you are going to prepare. So today our topic is going to be concentrated towards the production technology, which is going to have a more weightage of marks, and it is going to be 18 marks. Under production technology, you are having casting, you are having forming, you are having welding and joining process, etc. and etc. And today, as a part of this GATE class, we are going to see the questions relevant to welding and joining process. So, before moving on to the questions which has been asked in the previous GATE question papers, I want to give you a very short and small introduction about welding and joining process. So, welding. So, as you can see over here, welding is going to be a permanent joining process. As you can see in this slide, you can see some welding diagrams, and that involves coalescence or merging of two or more materials. More commonly, it will be a metal like this. So I am going to have two plates like this, and I want to merge these plates together, or I want to join these two plates together, as you can see over here. So welding is nothing but a permanent joining process by which these two metal plates are two different materials. Say it may be composites, it may be polymers, it may be plastics, or it may be a combination of one or two different materials or one or two different metals. So you are going to join these two plates. It may be metal or non-metal, or a metal with a non-metal, as you can see over here, and you are going to establish a permanent joint, and that process is going to be called as your welding. And how you are going to join these two plates together? You are going to join these two plates together by applying either pressure or heat or combination of both, and with or without the use of the filler metal, and this process is going to be defined as the welding process. So I define once again, welding is a permanent joining process in which merging of two or more metals or non-metals, or a metal with a non-metal, is going to take place by applying pressure or heat or combination of both, with or without use of a filler metal. And what is the need for this welding? The welding is going to establish a joint which is going to be permanently strong, which is going to be robust, and it is going to have a perfect leak-proof joint, as you can see over here. And this welding process is going to be one of the essential process for various types of manufacturing sectors, or in better words, it can be termed as a backbone manufacturing process for various sectors, including automotive sectors, aerospace industries, shipbuilding, marine industries, nuclear power plants, railway lines, even in computer sectors, especially with respect to fabrication of various components relevant to software and hardware, etc. So this is going to be the definition for welding. With this definition, we are going into the background, or we are going to see about the classification or different types of welding process. So next slide. As you can see over here in the next slide, this is going to be the various types of welding process. First type is going to be fusion welding. Next is going to be solid state welding. Third is going to be resistance welding, followed by the fourth type, which may be termed as bracing or soldering. And finally is going to be your adhesive bonding, as you can see over here. So we are going to see about what is going to be the example for each and every types of welding process or welding technique, followed by a small remark about that process, and finally its application, as you can see over here. As you can see over here, first type is going to be fusion welding. So fusion welding, here the metal is going to fuse with one another, so melting is going to take place, as you can see over here. First type is going to be fusion welding process. Best example is going to be arc welding, gas welding, and you can see electron beam welding, laser welding, etc. In all this joining process, the base metal is going to get melted, it is going to fuse with one another, and a permanent joint is going to take place. This is going to be called as your fusion welding process. And all the processes which are working under this principle, they are termed as fusion welding. And the best example is going to be, as I already told you, it is going to be arc welding, gas welding, laser beam welding, electron beam welding, etc. And where they are going to use? They are going to use in general fabrication purposes. Like in our house, we are going to have a gate. The gate is going to be joined by using the arc welding process or gas welding process. Then it is going to be used in construction of pipelines and in shipbuilding industries. Next comes your advanced type of the joining process, which is going to be called as your solid state welding. It is going to be called as your solid state, which means that the base metal is going to remain in its solid state, or in better words, melting of the base metal or melting of the parent metal is not going to take place, or it will not occur. So that is why the term solid state welding. The metal is going to remain as a solid without getting melted. And the best example for this type is going to be friction welding, friction stir welding, ultrasonic welding, explosive welding, etc. All these things are a best example for solid state welding. And the applications you are going to see that they are going to be used in aerospace sectors, fabrication of nuclear fuel components, etc. And third comes your resistance welding. Here how the welding is going to take place? Here joining of the two metal plates or joining of the materials is going to happen with the help of electrical resistance, or by applying electrical resistivity materials are going to join with one another, and that is going to be called as a resistance welding. Best example is going to be spot welding, seam welding, etc. And where they are going to find applications? They are going to find applications in the fabrication of nuts, bolts and various electrical components. Then comes your fourth type, which is going to be a unique or different type, which is especially used in the fabrication of various types of electronic components, especially the circuit boards, and in HVAC, that is HVAC means heating, ventilation and air conditioning. Then the fabrication of thin jewelry followed by thin walled tubes, and this is going to be called as your bracing and soldering. Here melting of the base metal is not going to take place like your solid state welding, but here it employs the use of a filler metal or filler rod. By melting the filler rod and fusing it, joining of the metals is going to take place, and it is going to be termed as bracing or soldering. Next comes your adhesive bonding. Adhesive means it is going to, like in the form of the adhesives, you are going to join the materials with one another, and that is going to be called as your adhesive bonding, which is going to be one of the recent welding technology emerging in the past few years. And example is going to be epoxy type of welding, resins type of welding, and as already you are going to see there, you are going to use adhesives, so you are not going to use any heat, or you are not going to apply any heat, and melting will not take place. That is, melting of the parent metal will not take place. Then what are all the applications? Where it finds applications? It is used for joining plastics, it is used for joining composites, it is used for joining polymers, etc. So this is going to be a short description about the various types of welding or joining process. Okay. So next, the third thing is going to be about, it is going to discuss about your types of the welded joints. So as I already told you, I want to join two materials or two plates, as you can see over here. So in what shape or in what form I am going to join these two plates? If you are going to see this, so I can join like this. This is going to be called as your butt joint. As you can see over here, this is going to be your butt joint, and if you want to join it one over the other, as you can see over here, it is going to be called as your lap joint, which you can see over here. Then comes your T-joint, in which one plate is going to be kept horizontal and another plate is going to be kept vertical, as you can see over here. This is going to be called as your T-joint, and you can see a T-joint fabricated for two different materials. Top portion is going to be your copper and bottom portion is going to be your aluminum. So two different metals are going to be joined in the form of a T-joint. So if you can see the alphabet letter T, it resembles the alphabet letter T, so it is going to be called as your T-joint, as you can see in this slide. And this is going to be your corner joint. You can see over here, joint is going to occur at the corners, and you can see in the form of the edge joint, the joint is going to take place at the edges, as you can see over here. So this is going to be about your different types of the welding joints. So with this idea, with this background, we are going to move on to the questions and problems which have been asked in the previous GATE year question papers, and we are going to solve it and we are going to find out the answer. So previous GATE question papers with respect to the subtopic welding and joining process. So if you are going to see first question, it has been asked in the year GATE 2017. What is lack of penetration in welding defects? So question is, what is lack of penetration in welding defects? Option A, failure of filler metal to fuse with the parent metal. Option B, failure of filler metal to penetrate into joint root. Option C, cracks either in the weld metal or parent metal. Option D, small holes throughout the weld metal. So this is going to be the question which has been asked for 1 mark. So you have to give the correct answer. So first, always read the question twice thoroughly and understand the question. The question itself will be having the answer. So if you are going to see this, what is lack of penetration? So what do you mean by the term lack of penetration? As you can see here, you are going to penetrate into something. So a joint means you have to join it permanently like this. Your structure is going to be attained over here. The joint is going to be attained in a permanent manner. So penetration is going to take place till the end of the joint or till the end of the thickness of the plates. So till you can see the back side, the joint or the molten metal has penetrated till the end. So this is going to be called as your complete penetration. So the question is about lack of penetration. So you have not penetrated till the end. So you have not penetrated till the end means root, up to the root you have not penetrated. So that is going to be lack of penetration. So I want to show you in the form of a simple photograph, as you can see over here. So this photograph shows you the lack of penetration in the front view. You are having some small defect. That defect is going to be called as your lack of penetration. In the cross section, if you are going to see, the molten metal or the filler metal have not penetrated till the root. That is shown over here. So as already told you, lack of penetration is a welding defect which indicates incomplete penetration, where the weld metal does not fuse completely with the parent metal exactly till the root of the joint. So till the root of the joint, here you can see the exploded view. So here it has not penetrated till the root. So there is a gap at the root. So it says that the penetration have not taken place in a complete manner. There is a incomplete penetration, or in better words, the penetration has not taken place till the root. That is going to be the definition for your lack of penetration. And why it is going to happen? It is going to happen due to many reasons. If you are not going to select a correct combination of welding parameters, this lack of penetration will happen. That is incorrect welding parameters. Then if you have not prepared the joint, or joint preparation had not been taken place in a proper manner, then this lack of penetration will happen. That is due to improper joint preparation. Then welding technique issues. If you have not selected the proper welding technique for fabricating the correct metal for joining the correct metal plates, then this will happen. Indirectly it means that you have selected a improper welding process or improper welding technique. Say for example, for joining nuclear components you have taken arc welding or gas welding. It is a improper joining process. Say for example, titanium cannot be easily joined, or there prevails a problem in joining titanium using conventional traditional techniques. And if you are going to select a arc welding or gas welding for joining titanium, then there comes a problem. Then several defects will happen, and one of the defect will be lack of penetration. And material issues. So for proper material, proper welding technique have to be chosen, and both have to be used in a correct manner. So these are all is going to be the problems which are going to lead to the lack of penetration defect. So coming back to our question asked, lack of penetration means, what do you mean by that? As I already told you, it is a incomplete penetration, which means that the molten metal have not fused completely with the base metal exactly till the root. Incomplete penetration. So till the root, the penetration has not taken place. So the correct answer, as we are going to see that lack of penetration. So failure of filler metal to fuse with the parent metal, and failure of filler metal to penetrate into the joint root. So here the word joint root is going to be more precise. It is going to be more perfect. So our correct answer is option B. So the correct answer for this question is going to be option B, which says that failure of filler metal to penetrate into joint root. Okay, so the third option, cracks, is not going to be the correct answer, and fourth option, small holes, is not going to be the correct answer. So the correct answer is going to be option B. Next, moving on to the next question. Second question is going to be again a multiple choice question. It is going to be for 1 mark. As you can see, in a resistance seam welding, the electrode is in the form of a, so it is in the form of a cylinder, flat plate, coil of wire, and circular disc. It has been asked in the GATE 2001 under production and industrial engineering domain. If you are going to see the question, as I already told you, read the question twice, understand the question thoroughly. The answer will be in the question itself. So I am reading the question again. In resistance seam welding, the electrode is in the form of cylinder, flat plate, coil of wire, and circular disc. To give the answer, first you understand what is resistance welding, then resistance seam welding. As I already told you, resistance welding is a joining process which you have seen under the third category of joining process, in which the joining of the metals is going to take place by applying the electrical resistance. By using electrical resistivity, the joining of the metals is going to take place, and here you can see the circuit diagram, and here you can see the side view. As you can see over here, two plates are kept one over the other. As you can see over here, these two plates are kept one over the other, and a circular disc. Yeah, the electrode in the form of a circular wheel-like disc is going to rotate over these plates, and because of this rotation, pressure is going to be exerted, and the electrodes are made out of copper, and this copper electrode discs, which are going to be in the form of a circular wheel disc, is going to generate electricity. So by applying electrical resistivity and by applying pressure, you are going to generate the joint, as you can see over here. So this is going to be called as your overlapping joints, and here you can see the electrodes. As you can see over here, the electrodes are in the form of a circular rotating disc. If you want a clear idea, you can see this diagram. As you can see over here, in this diagram you are going to have the plates which are going to be joined over here, and you are going to have two rolling electrodes. The electrodes are going to be rolled over the plates, and the electrodes are going to be in the form of, as they are going to roll, they are going to be in the form of circular rotating disc, and they are going to be made out of copper in many cases, and as they are going to roll over the plates, because of the electrical resistivity and because of the pressure exerted by the rolling electrodes, the joint is going to be take place, and the joint is going to be formed over here, as you can see over here. This is going to be called as your resistance seam welding, and the answer is very clear. What is going to be the answer for this question? As you can see over here, it is going to be made out of your circular disc. The previous options were cylinder, flat plate, coil of wire, circular disc. It is not going to be a cylinder. Flat plate, it is not going to be compulsory flat plate, it is not going to have any coil of wire, but instead it is going to have a circular disc. So the correct answer is option D, which is going to have the answer as circular disc. So this is going to be the answer for your second question. Moving on to the third question, as you can see over here, the metal powder used in dermite welding of steel is Al, aluminium, then followed by copper, then lead, and then tungsten. So what type of metal powder you are going to use in your dermite welding is going to be the question. For this, first you have to understand what is going to be dermite welding. This question was asked in the year 2004 under production and industrial engineering domain, and now you are going to see the answer for this. So as you can see over here, before going on to the dermite welding, how you are going to choose a welding process? So you are going to have a metal based on what type of material you are going to join, whether you are going to join two similar materials with one another, or you are going to join two dissimilar materials. Based on the type of the material to be joined, what is the thickness of the plates to be joined, or what is going to be the size and shape of the materials to be joined is going to play a very important role. And apart from that, for what type of application you are going to use this fabricated joint. So you are going to join two plates, or you are going to join two materials together. For what application you are going to join them, that is also plays a very important role in determining what type of welding technique you have to use. So what type of material you are going to join, whether dissimilar material or similar material, then what is going to be the size and shape of the material to be joined, for what application you are going to join them, all these things are going to play a very important, or it is going to play a very crucial role in determining the type of the welding technique to be employed for joining those materials. With this background, you are going to see about this. So you are going to have resistance welding, as we have seen in the previous question paper. It is going to be used for fabricating automobile components. Then comes your dermite welding. This dermite welding is most commonly used for joining the railway lines. The railway tracks you are going to have, they are going to have high cross section type of the bars. They are going to be joined using this dermite welding. Then comes your TIG welding, that is your tungsten inert gas welding, which is going to be used in aerospace and nuclear components, followed by your submerged arc welding, and it is going to be used in fabrication of shipbuilding structures. The hull structure etc. of the ships are going to be fabricated using this submerged arc welding. And then you are going to have your gas metal arc welding. As you can see, this gas metal arc welding, they are going to be used for joining different types of metals, starting with your stainless steel, aluminum, magnesium etc. And all these materials are going to be sensitive to atmospheric gases. So they are going to be fabricated using gas metal arc welding, which is going to be called as your GMAW. So this is going to be about the types of the welding techniques. So why we are going to see this slide? This slide gives you idea how you are going to choose whether you have to go for thermit welding, whether you have to go for resistance welding, whether you have to go for submerged arc welding, TIG welding or MIG welding, etc. All these things are going to be determined by what type of materials you are going to join, what is going to be the size and shape of the material, for what type of application they are going to be used, etc. So moving on to the next thing, it is going to be your thermit welding. So this gives you the diagrammatic view of the working principle of thermit welding. As you can see here, the thermit welding is a joining process in which materials are going to be joined by generating heat. Thermit welding is going to generate heat by an exothermic chemical reaction, and this exothermic chemical reaction is going to take place due to the reaction between the thermit, that is a mixture of metal oxide and aluminum powder. Here comes the answer for you. You are going to have a metal oxide, and the metal oxide is going to be, say for example, metal can be iron, so iron oxide is going to be mixed with aluminum powder, and both are going to be heated in a furnace like this. I repeat once again, in thermal welding process, you are going to generate heat. How you are going to generate heat? You are going to generate heat by putting aluminum powder and any metal oxide. That is, say for example, iron oxide and aluminum powder are going to be put in a crucible, and they are going to be heated, and due to this exothermic chemical reaction, heat is going to be generated, and this heat melts the material combinations, so that you are going to have your molten iron and aluminum oxide as the output products, and this molten iron is going to fuse with the stainless steel rods. As you can see over here, you are going to fuse with the stainless steel rods over here, and this is going to be the molten iron, which is the product of exothermic chemical reaction taking place between the aluminum powder and iron oxide. When the aluminum powder is mixed with iron oxide, you are going to get molten iron as the output product along with your aluminum oxide. This molten iron is going to fuse with the stainless steel rods or steel rods placed in the form of the railway lines, and you are going to establish a joint between one railway track and another railway track, and a perfect joint is going to be established, as you can see over here. So the thermit welding is a welding technique which is exclusively used for joining railway lines with one another, as you can see over here. And the answer for our question is going to be what type of powder you are going to use. It is very clear, you are going to use aluminum as the metal powder. So the option A is going to be the correct answer for this. It is going to be aluminum powder. Next, fourth question, you are going to have a numerical answer type question, that is NAT. It is going to be a numerical question. You are not going to have any option. You have to find out the option. So let us read the question. Let us see the diagram over here. It has been asked for 5 marks in the year GATE 2025. Previous year the question was asked for 5 marks. So you are going to give more importance to this, and you are going to see what is going to be the answer for this and how to solve this numerical answer type question. So read the question. 2 plates of thickness 10 mm. So the thickness is going to be, S is going to be 10 mm, as you can see over here, and each are to be joined by a transverse fillet weld on one side, and the resulting structure is loaded as shown in the figure below. So you are going to join 2 plates. Each plate is going to be have a thickness. The plate thickness is going to be 10 mm. So the, say for example, you are going to join 2 plates like this. You are going to join 2 plates like this, and the thickness of the plates is going to be, each plate is going to have a thickness of 10 mm, as you can see over here. So this is going to be 10 mm, and you are going to apply a load of 5 kilonewton. So change it to Newton, it is going to be 5000 Newton. So ultimate tensile strength which can be withstood by this joint after the fabrication of joint should be maximum 5000 Newton or 5 kilonewton. Then if the ultimate tensile strength of the weld material is 150 megapascals and the factor of safety to be used is 3, the minimum length of the weld required to ensure that the weld does not fail is dash mm, and they are asking you to round off the value to 2 decimal places. So you are going to have a load of 5 kilonewton on 2 plates each of thickness 10 mm, and the ultimate tensile strength of this joint is going to be 150 mm, 150 megapascal with a factor of safety 3. So for how much length? So for how much length you have to? So for how much length you have to make the weld? That is going to be the question. What is going to be the length of the weld, fabricated weld structure? For how much length you have to weld this flat plates? This is going to be the question. So you are going to see the answer now. So what we need? What we need is nothing but very simple, as you can see over here. It is going to be, what we need is nothing but you need, say for example, you are having a formula, force is equal to allowable stress into area. So this is going to be the value. What force you are going to give, that is going to be equal to the allowable stress into area. Then what is going to be your area? Area is nothing but, as you can see over here, it is throat thickness into length of the weld. You have to find out the length of the weld. You have to find out the length of the weld. So what is going to be your throat thickness T? It is nothing but plate thickness into sine 45 degree. So find out the throat thickness first, then you can find out what is going to be length of the weld, because if you are going to substitute over there, you can get the answer. So what is going to be your throat thickness? Plate length. What is going to be the plate length? It is going to be 10 mm into sine 45 degree 1 by root 2. You will get a value of 7.07 mm. This is going to be your throat thickness T. Okay. So you are going to have the throat thickness, which has been determined over here, as you can see over here. Then what you need? You need allowable stress. What is going to be the allowable stress? You are having very simple formula. Allowable stress is nothing but ultimate tensile strength divided by factor of safety. So if you see the question, read once again, they have given you the ultimate tensile strength as 150 megapascals. So you are going to put here 150 megapascal. What is going to be the factor of safety? They have given the factor of safety as 3. So it is going to be equal to 50 megapascals. So you have found out the allowable stress. Now what you need? You are having the formula, force is equal to allowable stress into area. Okay, you are having it. What is going to be the force? 5 kilonewton. It is given that they are going to have a maximum load of 5 kilonewton. So force is nothing but, it is going to be very simple. Force is nothing but 5000 Newton. That is 5 kilonewton is going to be equal to 5000 Newton. That is nothing but your force. So now you are having all the values. Force is equal to allowable stress into area. Force is nothing but 5000. This is equal to allowable stress. Allowable stress is nothing but 50 megapascal. How you got this allowable stress? Ultimate tensile strength divided by factor of safety, that is nothing but 150 divided by 3 is equal to 50. You are equating over here. This is given in the question. And what is area? Area is nothing but your throat thickness into length. How we got throat thickness? Throat thickness is nothing but plate thickness into sine 45 degree. So you got the value of 7.07. So what you are going to do? 5000 is equal to 50 into 7.07 into length. That is going to be the length of the plates. So what is going to be the length of the plates? 5000 divided by 50 into 7.07. When you are going to use the calculator and you are going to find out the answer, you will be getting 14.139 or something. Round it off to 2 decimal points as you already shown over here. So 14.14 mm is going to be the answer for this question. Very simple, but it has been asked for 5 marks, which has been asked exactly in the previous year in 2025. So I am giving a summary. So from the given data, what you are going to take is nothing but, you have to take plate thickness is nothing but 10 mm, which is nothing but equal to S. Then ultimate tensile strength, you are having 150 megapascal, write it down. Then factor of safety, then load applied is nothing but your force. Take it as 5000 Newton. So go to this formula, equating force with strength. It is nothing but force is equal to allowable stress into area. First find out area using this formula. Area is nothing but throat thickness. So what is T? T is nothing but plate thickness into sine 45. Already you are having plate thickness as 10 mm. Substitute you will be getting throat thickness. So area is nothing but T into L. You got throat thickness, keep it as it is. You does not know L, you take it, substitute here, you will be getting all the values, and the final answer is going to be 14.144 mm. So moving on to the last question of today's class. So the answer, as already told you, it is 14.14 mm. It has been asked for 5 marks. So last question, as you can see over here, this is going to be a unique question. At last I will be telling how this is going to be unique. It has been asked in the year GATE 23. It has been asked just 2 years before, in the year 2023, and the question is like this. Two surfaces P and Q are to be joined together, in which of the given joining operations there is no melting of the two surfaces P and Q for creating the joint. So you are going to join two plates. Okay, and you want to join these two plates without melting the base materials. That is, you have to join them without melting the base metal, and out of these joints, which are all going to be the joining process, in which you are not going to have any melting of the base metal. That is going to be the question. Option A, arc welding. Option B, bracing. Option C, adhesive bonding. And option D, spot welding. So we have seen first during the introduction section the various types of welding process. First type is going to be fusion welding. So fusion means melting of the parent metal is going to take place, and under that fusion welding you are having various examples. First is going to be arc welding, gas welding, laser beam welding, electron beam welding, etc. And there comes your arc welding. So here melting of the material is going to take place. So this is not going to be the correct answer. So as you can see over here, this is not going to be the correct answer. So this is wrong. Next comes your bracing, then adhesive bonding, and then spot welding. So bracing, adhesive bonding, and then comes your spot welding. So if you are going to see this, as already told you, arc welding cannot be a joining process suitable for joining the materials P and Q, because they should not get melted during the joining process. But arc welding, as it comes under the fusion welding process, here melting of the base metal will happen surely, and this is not going to be a suitable process. Then comes your bracing. As I already told you, bracing is going to be the third type of welding technique in which melting of the base metal will not take place. But here you are going to use a filler material, or you are going to use a filler rod, but melting of the metal will not take place. So this is going to be correct answer. But anyway, you are going to have two options. Let us see those options also. Third comes your adhesive bonding. As I already told you, adhesive bonding is nothing but here the joining of the materials is going to take place by using adhesives. So you are going to use a adhesive and you are going to join the materials together. So it is going to be called as your adhesive bonding, and here also melting of the metal will not take place. So this is also is going to be the correct answer. Next come your spot welding. As I already told you, spot welding, it is going to be a category under resistance welding. So here the joint is going to take place by electrical resistivity, and joining of the material takes place by melting the base metal. So here P and Q will get melted. So this is also is not going to be the correct answer. So the correct answer is going to be here. You are going to have two correct answers. One is going to be option B, bracing, and another is going to be option C, adhesive bonding, as you can see over here. And here I have given the explanation which I already told you in the form of the theory. As melting occurs, it is not going to be the correct answer for arc welding, but for bracing, melting will not take place. Even though they are going to use a filler material, here melting will not happen, and this is going to be the correct answer, followed by adhesive bonding. Here you are going to use adhesives and you are going to join the material. So this also is going to be correct, as melting will not occur for P and Q. But in spot welding, it is resistance welding where you are going to use electrical resistivity and melting will happen surely. So here this is not going to be the correct answer. The correct answers are, as you can see over here, it is two options, answer B and C. So this is going to be, as I already told you, it is a unique question because it is comes under multiple select question. So two answers will be there. So as you can see over here, this is going to be multiple select question. And with this, we are coming to an end. I sincerely thank you for your patience listening. I will be coming back to you soon with more questions on welding and joining process. Thank you one and all.